Welcome to the RAID special for Gigabyte X570 Aorus Master motherboard. This video is for people who own this motherboard or those who are thinking of getting it and would like to know how to set up a RAID array and what to expect from it. It will be divided into several parts, so feel free to jump into whichever you like. I'll cover in detail the installation of Windows 10 Pro from a flash drive on a RAID1 array consisting of two M.2 NVMe SSDs, because I think that's a scenario most people will want to use to improve the reliability of their systems and their performance. I'll also cover the rebuild scenario where one of the drive fails and needs to be rebuilt, because I think it's practical and something you might need to use in the future. Hopefully not. Then I'll run some benchmarks so that we know what are the differences between running a single drive and a RAID1 array. Before we begin with the installation, I think it would be wise to adjust your expectations concerning the RAID setup. So I'll explain the differences between RAID 0, 1 and 10, which are the options that this motherboard supports. I'll also cover the conditions that need to be met so that the RAID array works properly. So, let's begin. RAID stands for Redundant Array of Independent Disks. The letter I used to mean inexpensive back in the 1980s because it was a solution which, compared to IBM solutions which were using more expensive drives, was considerably cheaper. If you want to know more about RAID's history, I recommend watching an interview with David Patterson, one of the RAID fathers, on Lex Friedman's channel. Now let's begin with RAID 0. The minimum number of drives necessary is 2, and the maximum number of drives according to the manual is 8. It doesn't mean this number is valid for RAID 0 in general, it's just for this motherboard without any standalone RAID controllers. RAID 0 isn't fault tolerant because this setup has no redundancy. Therefore, it is a little strange that it's even called a RAID, because the first letter of RAID stands for redundant, and this setup lacks this main attribute. Anyway, if you use it, you won't lose any effective capacity of your array. So if you have two drives, 1 terabyte each, and put them into RAID 0 array, you'll have 2 terabytes of capacity available for your files at your disposal. RAID 0 improves the speed of read operations because you can read from both drives simultaneously. The speed improvement will differ with different file sizes, controller configurations, settings, and of course with different drives. The improvement of write operations is also significant because you are writing to both drives different data simultaneously. Both reading and writing operations of large files may reach even double the performance compared to using a single drive. The disadvantage of this solution is that if any one of the drives fail, you lose all the data. Because even if one of the drive survives, the second half of the files, which are split up into blocks, are stored on the drive that failed. Therefore, if you use only a single drive, your data will be safer with 50% less probability of failure. The advantage is that you get the whole capacity of both drives with no overhead for parity, which is present, for example, in RAID 5 or RAID 6 configurations. And you don't sacrifice any capacity for redundancy, like in case of RAID 1 or RAID 10, at which we'll look at in the next few minutes. So let's start with the RAID 1. The minimum number of drives necessary is 2, and it's also the maximum. RAID 1 is fault tolerant because one of the drives acts as a mirror. This means that the same data is written on both drives. Because of this redundancy, you'll sacrifice the effective capacity of your array for the security of your data. So if you have two drives, 1 terabyte each, and you put them into RAID 1 array, you will have only 1 terabyte of capacity available for your files at your disposal. RAID1 improves the speed of read operations because you can read from both drives simultaneously. The improvement will differ with different file sizes, controller configuration settings, and of course with different drives. So in this regard, the performance will be similar to RAID 0. However, there is no improvement of speed of write operations because you are writing the same data to both drives simultaneously. The disadvantage of this solution is the effective storage space is only half of the total drive's capacity, and the drive space therefore becomes more expensive. The advantage is the redundancy of data, because if one of the drives fail, all data can be recovered quickly. All that's needed is copying all the data from the surviving mirror drive to a new drive. Finally, let's have a look at ARAY 10, which combines characteristics of both RAID 0 and RAID 1. It's sometimes called stripe of mirrors. The disks within the group are mirrored, but the groups themselves are striped. The minimum number of drives necessary is 4, and the maximum according to the manual is 8. This also doesn't take into account any standalone RAID controllers you might put into PCIe slots. It is fault tolerant because 2 drives act as mirrors. Because of this redundancy, you will sacrifice the effective capacity of your array for the security. So if you have 4 drives, 1 terabyte each, and put them into RAID 10 array, you will have only 2 terabytes of capacity available for your files at your disposal. RAID 10 improves the speed of both read and write operations. The improvement will differ with different file sizes, controller configurations, settings, and of course with different drives. The disadvantage of this solution is that the effective storage space is only half of total drive capacity, and the drive space therefore becomes more expensive. The advantage is of course the redundancy of data, because if one drive fails, all data can be recovered quickly. All that's needed is copying all data from the surviving mirror drive to a new drive. Now that we know the advantages and disadvantages of different RAID setups, we can have a look at characteristics that the drives for RAID should have. First, they should be from the same brand, same model, same capacity, but ideally not coming from the same batch. Why? One reason is the speed, because you don't want the faster drives to be waiting for the slower ones to catch up, because all data on all drives in a RAID array has to be in sync. And the second reason is the capacity, because combining bigger and smaller drives would result in a waste of space, because the allocated space on each drive of the RAID array has to be of the same size. Now let's demystify the widespread same batch nonsense. First, let's have a look at it from point of logic. If you have 2 drives which are exactly the same, that means they share the same physical characteristics, they are made of same parts which share the same flaws, and you run them exactly the same amount of time under the same conditions, what do you think is the probability that they will fail at the same time? Well, one would say pretty high, close to certain. But you may say, okay, that's a nice theory, so how does it work in reality? It's been probably more than 10 years ago when I used to work for a server hosting company and we had several hundred servers. I used to work as a technical support, and one day we had this situation where 2 mail servers died within 24 hours. So we were analyzing what happened, and guess what we found out? That the servers, which were both running RAID 1 arrays, died because these disks were coming from the same batch. Well, you may say, okay, that's a nice story, but it could have been just a coincidence which happens once in a century. I knew this, so I asked a guy who works at a bigger company which has more than 3,000 servers, and I asked him what's his take on it. And guess what he replied? He said, this not only happens sometimes, this happens all the time, every week. So that's for the probability of 2 drives failing at the same time. The practical outcome for you from this story could be that if you want to decrease the probability of 2 drives failing at the same time in your RAID 1 array, you could buy them from different shops so that you increase the probability that they are not coming from the same batch. This leads me to one important thing that needs to be addressed, and it is that RAID is not a backup. It is a technology which can be used to improve the reliability of a backup solution, but itself, it lacks its characteristics. Backup is something that has to be separated from the original by space and time. What does it mean? It means that a backup system is physically separated from the original, so that when something happens to the original, it doesn't happen to the backup physically. And in time means that it was created in the past, so that when something happens in the present, it can be recovered from what was saved in the past. So that's something that needs to be taken into consideration. RAID will not protect you from accidentally deleting your data, from a virus corrupting it, or from a system update making your system completely unusable. So keep this in mind, and now let's move on to the practical stuff. Let's have a look at creating a bootable Windows installation disk on a flash drive. The first thing you need to do is to Google Windows Media Creation Tool, which will direct you to the right page on Microsoft's website without the necessity of knowing the exact URL. You'll click on this download link. Here, you'll click on download, which will download a small file called Media Creation Tool with an actual number of its version. Then you need to open the file and wait a few seconds for it to start. You'll need to accept the terms of use to be able to continue. So click on accept and wait until the next part loads up. You'll need to click on create installation media for another PC and then click on next button. Unclick the recommended options because you'll probably not be installing it on the same PC where you are creating the bootable drive. Select your language and keep Windows 10 selected in the edition. You'll later be able to pick the exact edition during the actual installation. And leave 64 bits selected and hit the next button. Leave the USB flash drive selected. Using DVDs for installation is the past. It's both slow and wasteful. So hit the next button. It will show you drives which are currently available. You don't want to use them unless you have connected your flash drive already. You need to use an empty flash drive which has a minimum of 8 GB free capacity. So insert it into your USB port. It should make a system sound, which you just heard, and show you the drive notification in your bottom right hand corner of the screen if you have Windows 10 installed on your computer. Click the refresh drive list button. Your flash drive should appear immediately, and then select it with a left click. Then hit next. This will initiate a process of creating your bootable installation drive, which will take a couple of minutes. The speed will depend on your internet connection and the write speed of your flash drive. When it's finished, the message "Your USB flash drive is ready" will pop up. Click on Finish. This is what the contents of your drive should look like in your file explorer. The installation files will take around 4 GB of space on your flash drive. Leave it still connected in your USB port because we will download and copy RAID drivers on it. Downloading RAID drivers for your motherboard. To download the RAID drivers, go to your browser. I'll be using Edge because it's part of Windows. Type in gigabyte.com and press enter. Then click on Products. In the motherboard section, click on Aorus Gaming. Select the chipset from the menu. In our case, it's X570. Click on Gigabyte X570 Aorus Master. Then click on Support and SATA RAID/AHCI, which will show current versions of drivers for different versions of Windows. At the time of making this video, the most recent was Windows version 2004, so I'll download both RAID drivers. One will be used during the installation of Windows and the other after the Windows is installed. The first one is downloaded and now the second one. I'll open Windows File Explorer and here I'll click on our previously created Windows installation drive called ESD USB. I'll create a separate folder called RAID into which I'll unpack the files I have just downloaded. This way, I won't have to use a separate USB drive with RAID drivers during the Windows installation. So now I'll go back to the web browser, open the first zip file and drag its contents, the x64 directory, to RAID directory on my flash drive. Now I'll unpack the second file to the flash drive as well. It will unpack quickly, it will be dependent mainly on the write speed of your flash drive. So this is how the content of your flash drive should look like before the installation. Preparation phase is finished, so it's time to have a look at RAID1 setup in BIOS with two NVMe M.2 SSDs. Before we begin, let's make sure all these conditions are met. Disconnect any drives which contain any valuable data. Only two empty M.2 SSDs should be connected to the motherboard. We want to avoid any potential data loss made during the installation. You may reconnect your drives after the installation is successfully completed. Make sure you have USB flash drive with MS Windows installation program and RAID drivers ready. Also make sure to have the latest version of BIOS installed on your motherboard. This video was created with F11 version of BIOS installed. If you don't know how to do it, check out the video called Building a Home Server on my channel. There is a chapter dedicated to it. Or you can use the motherboard's manual for reference. Make sure optimized defaults are loaded in your BIOS. This is where this part of the video begins. It will be shown in the next minute or so. It will make sure that the next two conditions are met, that your CPU is not overclocked and that the XMP profile for memory modules is not loaded during the installation. But before we begin, let's check the hardware first. When we look at the motherboard, we can see that I placed the SSDs into first and second slot, and I left the third one empty. I'll switch on the computer and start pressing delete. So now we're in the BIOS. I'll press F2. I can see that both drives are present. Now I'm going to load the optimized defaults to make sure we are on the same starting point. so I'll click yes. Now I'll press F10 and restart the computer. I'll keep pressing delete. Now I'm going to go to advanced mode, so I'll press F2. Here I'll go to settings, then I/O ports, and as you can see, RAID Expert 2 configuration utility is not available yet, so I need to enable it. So we'll go to SATA configuration. We'll leave AHCI mode on, and now we'll go to NVMe RAID mode. I'll press enter and select enabled. Then I'll use my right arrow key and go to boot. Here I'll disable the CSM support. I'll press enter and select disabled. To confirm these changes, I'll press F10. This is what the changes look like, as you can see. And I'll press enter. It will restart the computer again, so I'll keep pressing delete to get into the BIOS again. So we are in the BIOS again. Now I'll go to settings and I/O ports. And as you can see, RAID Expert 2 configuration utility appeared. So I'm going to go there. Here I'll go to controller management. I'll go to rescan disks. As you can see, both drives are ready, so we can continue. So I'll press OK and then escape. Now I'll go to physical disk management because we need to initialize the drives before we can use them. Here I'll go to select physical disk operations. Then I'll go to initialize disk. I need to enable both drives. I'll click on each one and select enabled. Same with the second one. And I'll press OK. This will delete all the data on the drives, but since they're empty, I don't care, so I'll press yes. Now the disks are both initialized, so I'll press escape. Here I'll go to array management. And as you can see, there is only one option available, and that is create array, so I'll press enter. Now I'm going to pick the RAID level I want to use, so I'll press enter. There are three options here: RAIDable, RAID 0 and RAID 1. Pick which one you like. In my case, I'm going to be installing the OS, so only one of the options makes sense, and that is RAID 1. So I'll pick RAID 1. Now I'm going to select the physical disks which are going to be part of this array. So I'll click on physical disks. I'll use both drives, so I'll check all. And now I'll apply changes. Here I'll leave all the parameters as they are. As you can see, you can select different cache tag size, but for NVMe SSDs, 256 KB is recommended, so I'll leave it as it is. Read cache and write cache will be left as they are. So now I'm going to create the array. I'll press enter. And now when I go back, I can see that array 1 is ready. What I need to do now is to press F10 and confirm the changes that I made. This is going to restart the computer. I'll keep pressing delete. Now I'll go to easy mode. And as you can see, you cannot see any drives here because now they are in RAID. So now I'm going to go to advanced mode. I'll press F2, settings, then IO ports, then RAID expert configuration utility, and now I'll go to controller management, rescan disks. As you can see, both drives are online, that means they are used, and ARAY1 is ready. So I'll press OK, then a couple of times escape. Now I'll take the flash drive which we prepared before, which contains Windows installation and RAID drivers. I'm going to plug it into USB port and restart the computer. That means now I'll quit without saving, and when it restarts it will start loading the Windows installation program. So let's do it. I'm not pressing delete anymore. As you can see, Windows installation is loading. Here I can select my preferences like language, time and keyboard, so I'll leave it as it is and press next. Now I'll press install now. There is no need to enter the key now, you can do it later, so I'll click on I don't have a product key. Now I have the option to pick which version of Windows 10 I want. In my case it's going to be Windows 10 Pro. I'll click next. To be able to continue, you have to accept the license terms, so I'll accept them. Now we need to use the custom install because we'll be loading the RAID drivers. So I'll press custom install Windows only. As you can see now, Windows doesn't see the RAID array yet, so we need to load the drivers. I'll begin with the first one. I'll click at load driver. Here I'll click at browse. Now I'll go to my flash drive, then to RAID, X64 and NVMe RAID. I'll press OK, and there is one driver which needs to be loaded first. Altogether there are 3. This is the first one, so I'll click on it and click next. Now I need to load another driver, so I'll click on load driver again, browse, NVMe RAID. Now second driver appeared, so I'll load this one, RC RAID, and press next. As you can see, Windows now recognized both drives as one, so I'll load the final driver. And the last one which I'm going to load is RCCFG, and press next. RAID drive is now ready for installation of Windows. I'll select it and press next, and the Windows installation already began. You can leave the flash drive in the USB port, it will have no effect on the installation. Expect Windows to restart several times, so be prepared. So this is the first restart. So now it restarted again. Here you can pick your region, so I'm going to stay with US. Now the keyboard. If you want to add another keyboard, that's possible, but I'll skip it. Now you can connect to your network, but I wouldn't do it at this point, so I'll go I don't have internet. I don't want to use any of these options now as well, so I'll go with continue with limited setup. Now I'll pick the name for this PC, so it's going to be test PC. And I'll press next. Then I'll create password and confirm it. Then I'll need to answer the security questions. Now, I won't be using any of these, so I'll click no everywhere. You can do whatever you like here. No. Not now. And voila, we are in the Windows. So we will now install the final RAID driver. I'll go to File Explorer. Here to ESD USB flash drive. And here to the directory which I prepared before, RAID. Here is the Windows driver, so I'm going to install it. And as you can see, RAID Expert 2 appeared on the screen, so I'll double tap. It tells me that I should run it as an administrator if I want to make any changes. I'll close it. So I'm going to right click the RAID Expert because it requires to be run as administrator. And as you can see, this is our RAID array that we created. And the state is online, so it's already running. Also, look at the naming of the disks. This one is 01 and this one is 11. And they have different serial numbers. So what I'm going to do now is to run some benchmarks to find out what's the speed with NVMe RAID1. And then I'm going to remove one of the drives to find out what is the speed with one drive. I'm going to format it to simulate the failure, and finally I'll try to recover the partition so that we can see how the RAID array is rebuilt. Let's have a look at the performance of RAID1 in CrystalDiskBenchmark. The maximum speed achieved during this run of the test was 5.5 gigabytes per second read speed and 2.1 gigabytes per second write speed, which is not bad for a couple of relatively cheap SSDs. Now let's have a look at ATTO Disk Benchmark in RAID1. As you can see here, the highest read speed achieved during this run of the test was 6.2 gigabytes per second, and the highest write speed was 2.1 gigabytes per second. Here you can see clearly that the bigger the file size, the faster is the write speed and also the read speed. Now we know the results of the test with two drives in RAID1. So next logical step is to remove one of the drives physically from the motherboard and format it to simulate a failure. Then I'm going to run these tests only with one drive present, and later on I'll put the second drive back and we will make a RAID array rebuild to see how long it takes and what's necessary to do to make it happen. To simulate the drive failure, I will remove one of the SSDs and format it. Now we're going to look into the BIOS to see how it looks like when you remove one of the drives of a functioning RAID1 array. The array status is critical. That means the RAID array is in critical condition because I removed one of the drives. So what I'm going to do now is to boot back into the Windows and we will see what happens. So now we're in the Windows and now we can see that RAID Expert 2 is saying that Array 1 has gone critical. So let's look at it. Yeah, we can see that there is a problem. So let's look into RAID Expert 2. And we can see here that the RAID is in critical condition because one of the drives is missing. The disk which is there now is 01, and the one which I removed was from the second slot and it was disk 11. So now we know how the disks are named, that the first slot is 01 and second slot is 11. Now that we know that one drive is missing, it's time to test it, because we need to know the difference between having a single drive and the RAID array. Now that we have removed one drive, we can see how it's going to perform compared to RAID 1 array. So let's do it. Now we know the peak numbers with a single drive. It's 3.4 gigabytes per second read speed and 2.1 gigabytes write speed. Let's have a look at single drive in ATTO Disk Benchmark. As you can see here, the highest read speed recorded during this run of the test with a single drive was 3.4 gigabytes per second, and the highest write speed was 2.1 gigabytes per second. The same follows here as was with RAID 1. The bigger the file size, the higher the write and read speed. This is important because OS mostly consists of small files around 4 kilobytes file size, so later on we will compare them side by side. Now I'm going to put it back. Now I installed back the second drive into the second slot on the motherboard. We'll look at how the RAID array setting look like after it's been added. The drive is formatted. So now I'll go to RAID Expert 2 configuration utility. Here I'll go to Controller Management, Risk and Disks. As you see, the first drive 010 is still part of ARAY1, which is in critical condition and it's online. And the second drive, which I added back and formatted, is now visible as a new drive, and it's part of ARAY2. So I'll go back and I'll exit without saving. So now we are going to the Windows. What I'm going to do now is to run the RAID Expert 2 as an administrator. I'm going to right click on it and run as administrator. It is showing me that the drive is in critical condition and that there are 2 arrays available. This is the drive that I just added and which has been formatted, so it doesn't know that it has previously been part of this array. So now it's visible here as disk 11. What I'm going to do now is to delete this array so that I can free this disk for the RAID array. That means I'm going to delete it, and then I'm going to make it available for RAID1 array. So I'll right click on ARAY2 and click on delete. It will ask me, so I'll confirm. Now this disk is ready, but it still hasn't been assigned for RAID1 array, so I'm going to right click on it and I'll assign it as a global spare, which means that the RAID1 array will be able to use it for its rebuild. So I'll press OK, and as you can see, the restore has already started. This is the source, and this is how it's going to look after the rebuild. So now we'll have to wait some time and see how the rebuild goes. Now you can see that the RAID array rebuild is finished. Both drives, the 01 and 11, are online and RAID 1 is fine. As you see, it took about 26 minutes, so it's pretty quick, especially when you're using RAID 1 and not RAID 5 or RAID 6 array, which require parity, which takes a long time to rebuild. The RAID array rebuild was quite fast and easy, so I think that's a great solution if you want some reliability for your OS. One thing I want to mention, just to give you a full disclosure, is that it is possible to set the new drive as global spare in BIOS before entering Windows. If you do it, it will begin rebuilding the RAID array automatically immediately after entering Windows. Because the rebuild is possible only in Windows and not in the BIOS, like it is possible with some motherboards with Intel chipsets, it makes no sense to go to BIOS first and do it in several menus, because in RAID Expert it's much easier. So now we can move on. Let's compare the results of the tests between two 148GB M.2 SSDs in RAID 1 and a single drive in CrystalDiskBenchmark. When we look at the write speeds, we can see that they are very similar, with slight advantage for a single drive. It is probable that it is caused by the necessity for syncing the writing operations in RAID 1 array. The biggest difference is noticeable when writing large number of small files at the same time, where the RAID 1 array loses almost 50% of speed compared to a single drive. To be sure it's not a one-time error, I repeated the test 3 times in a row with the same result. When we look at the read speeds, it is obvious that it is the area where RAID1 shines. In sequential reads of large files, RAID1 gains 50 to 62% advantage over a single drive. And when reading many small files, the performance in this test reaches from 28 to 100%. Now let's look at ATTO Disk Benchmark. It shows us read and write speeds of files with different file sizes, which will give you more realistic view at what you can expect when working with these files of certain size. When it comes to the write speed, one drive performs very similarly to a single drive. The differences are within a margin of error. They are not as consistent in favor of a single drive as they were in CrystalDiskBenchmark. When it comes to read speed, single drive has very small advantage when reading files which are 2 kilobytes and smaller. And with all other file sizes starting from 4 kilobytes up, RAID1 takes the lead. The differences are ranging from 4% with 4 kilobyte files to almost 60% when reading 64 megabyte files. I also measured the boot time from a completely switched off computer into Windows. A single disk took 40 seconds to boot and RAID1 only 35, which makes 12.5% difference, and it's noticeable. I tried it several times and the results were consistent. Overall, I hope this comparison gave you some idea what you can expect from RAID1 ARAY. I'll be definitely using it. I guess this video was long enough, so I'm not gonna make it any longer. Thank you for watching and I hope to see you next time.